Okay, good morning, good afternoon, anytime you are, or good evening, anytime you are watching this video. This is a makeup for the first lab that did not upload very well. So I'm going to start sharing my screen. This is DCE110 lab internet to computer aided design. We are using the multi-sim electronic workbench, and we have agreed that we'll be using this tutorial to guide us through. So let me quickly do a brief introduction. Um, Electronic Workbench is a simulation package for electronic circuits. It allows you to design and analyze circuits without using breadboards, real components, or actual instruments. Electronic Workbench allows click and drag operations, which will make editing our circuit fast and easy. In Electronic Workbench software, you can change parameters and circuit components on the go. And you can also allow, which can also allow you to make what if analysis straight forward. So you can do what if analysis. If I change this, what will happen? If I add this, what will happen? So these are the opportunities we have in a simulation package like Electronic Workbench. As you know, we are using the trial version of multi-sim version 8 thereabout. So this tutorial is intended to introduce us to the Electronic Workbench basic features as quick as possible. It will lead us through the fundamental steps of putting a circuit together and analyzing its function using the instruments. The final parts of the tutorial consist of two exercises that try to illustrate the power of Electronic Workbench. It also tries to encourage you to apply the what-if approach to circuit design. This will greatly help you understand electronics, uh, the workings of electronics. If you use electronic workbench in an interactive manner, you'll be able to find out how circuits behave, or what happens if you change a component, and you also see how um, instruments in the lab can be quickly used and operated without having the physical equipment in the lab. So you can make change to the circuit you are working on. You can make changes to the circuit you're working on. You can observe the effect that these changes have, and then you can try to understand them. So with this, Electronic Workbench puts very little constraint on parameters. So you don't have to be scared. Don't be afraid. Don't just change things by 10%. Try out what happens when you change them by a couple of orders in magnitude, by changing them with higher percentage. For instance, you can try, 10 kilo ohms, and then you can also try 5 ohms and see how the change in resistance value affect that circuit. And this will help you in understanding design principles. And this will also teach you the act of designing electronic circuits. So before you now graduate into more advanced level of in-depth analysis of circuits, traces, you can go into what we call traces analysis and other um, direct current analysis, and all those things. So directly printing from electronic workbench schematics and graphs does not usually produce satisfactory results. So you may not be able to print directly from it because, well, number one thing is that we're using a trial version for educational purposes. Number two is that you cannot copy the files to another computer. So the best thing is for you to follow the methodology we have shown you in the class, in the lab. Because if you want to print from electronic workbench directly, it can lead to waste of paper. It can be telling you page one, only give you small portion, then page two, page three, like that. But when you use what we call screen capture, and then you paste, copy and paste into application like Word document, Microsoft Word. From there, you can adjust, you can put them in good place, and then before you print. Now, quickly, we now move to the practical proper, and I'm going to demonstrate how you can print also, so that you will not have any problem. I've noticed that a lot of you are having challenges when submitting your assignments. This is not ideal. You should have watched this video before that, or you should have contacted someone that was in the lab when we did the first practical, where I showed everyone how to do the screen capture and copy and paste in Microsoft Word before you print. Now let's just quickly open. I have the icon here on my screen. I'm going to open it, and I'm going to um, change my uh, I'm going to change my, yes. So now I've changed to the electronic workbench screen. That's the circuit window, which will allow me to demonstrate very quickly the circuit. So I will just show the circuit I'm working on. I'll be looking at figure one of our tutorial, or that is our lab manual. Now, you open the workbench after you have installed it. You have done the installation. Some of you have already installed. So those who have not installed the application on your laptop or on the systems should do that. And then don't forget to do the first setup and then the update. And then you uh, follow the instruction, the installation instruction in the README file in that application folder given to you. Now, to open the electronic electronic workbench, click on the installation icon, the application icon, anywhere it is or wherever you have put it. You will see an empty circuit window like this, and you will see two bars. You will see circuit toolbars and the common file management, like the word processing. You see the edits, you see graphic tools, all these are here. Then you see a path bin from which you can select your circuit element. These are the path bins. Okay. In electronic workbench, we have master database, we have corporate database, we have user database. Master database is the one that came with the package, with the software, electronic workbench. We're using multi-sim uh, um, the one that multi-sim developed. Now, when you open it, you click, you have the master database. That is the one that all the components and circuits that uh, have been built and they have been defined in the software are put together. That is where they are located. That is where they are located. That is where they are located. Okay, that's where they are located. Okay, so when, as I said, you have the master database, you have the corporate database, you have the user database. Let me quickly explain this because it's very important for you to know what they are. As I've said earlier, master database is comprising all the components that have been designed, uh, that have been already, simulated and compiled and kept in the software in the multisim electronic workbench. The next one is corporate database. Corporate database is the one that the company you are working with. This is for the company. The company you are working with may want all the components and circuits that they design or they uh, you know simulated, all these things that will be kept for central use. Then we have the user database. It's the one that individual user of electronic workbench they create. The components that individual users of electronic workbench create will be kept in the user database. So you will need to save it with a different name apart from the one in master database. So anytime you save a component, probably the one you have modified or the one you have created yourself, you can save it in the user database. And then we have, when you pick, if you pick corporate database, you see that there's nothing there because we don't have any here. And when you also pick user database, you see that there is nothing there because I've not saved anything here. In my former system, I've used a lot of time for teaching. I have saved a lot of user database, user created component, the one I created, modified from master database, and they will be there. So now I will just be referring to the master database. That is where you have all these sources. You have power supply, you have AC, DC, ground. That's where you get them. Then you have the signal voltages. This is where you have the AC voltage, uh, amplitude modulated voltage, clock voltage, exponential voltage, frequency modulated voltage, piecewise linear voltage, pulse voltage, thermal noise. Then you have signal current, the same thing, AC current, clock current, DC current, exponential current, frequency modulated current, piecewise linear current, and pulse current. And then you have control function. All of these control limiter. Uh, I can increase it so that you can see control limiter block, divider, multiplier, non-linearity dependency, and all this they are there. Uh, if you check the next one, control voltage sources, you see all these ones, and when you see them, there you discover that whatever you need, when you select, you always see, let me move my this thing. You always see the picture, the symbol by the right hand side here. When you select each of them so that you know exactly what you will be using in the in your circuit schematic as control current sources. You see these are the just two ones you have here. And so um, I can minimize again. Now, these are with the sources. Then we also have basic. This is the basic components. We'll be using more of basic virtual. Basic virtual refer to those, virtual components that can take any value. You want to use virtual, um, you know, capacitor, inductor, and all that. When you come to resistor, you have rated virtual, you have um, even in basic virtual, um, um, you can see you can see different virtual component here. All this, then you can see a lot of all of this. When you come to um, basic virtual, you can pick. If you cannot get the values of the resistors, you can have the ohms, you can have the kilo ohms, you can have the mega ohms. So these are the things. And then also you have what we call the tolerance value. You have 1%, you have 5%. So when you click on 1%, you will see only component with 1%. 1% is extremely precise. So it means that when you talk about tolerance value, what you are saying is that the value will not deviate more than 1%. So if you have 10 mega ohms or 1 mega ohm, is going to deviate just by 1%. That means you can have plus or minus 1% in the value. But if you go to so when you have 5%, it means that the value can change the maximum, the lower, and the lower bottom by 5% of its stated value. So the same thing with the ohms, mega, kilo ohms, like that. So the lower the percentage of the tolerance, the more expensive the component, and the more precise, the more accurate the value of that component will be in the circuit. So take note of that so that you can already understand that. So, and when you go to the market, there are ways we label component like resistor. They have color code that can show you which one is 1%, which one is 5%, 10%. There is even 10% for some. So you have a lot of things in the basic. You have connectors, you have transformer, you can use for a lot of things. You have inductor. You want to design your power supply, you can do that. You have capacitor, electrolyte capacitors. You have a potentiometer. You can see them here. You have resistor packs, and then you have surface mount resistor. They're very, very small surface mount resistors, and you can see that surface mount resistors seems not to have uh, percentage um, percentage tolerance. And you have inductor, surface mount inductor. You have inductors here you can use in your circuit. Also, we have diodes. Different. You have diode virtual. If you don't know the value of the diode, you can pick any of these diode virtual and or Zener diode virtual. If you don't have the exact value available in this set, in this the number, the component number not available, you can pick that you can that you can that that you're supposed to use. So you can pick diode virtual and pick either Zener diode or diode virtual. You have Zener virtual or diode virtual. Then you go to this one. These are the ones that you can see. You click on them, you can see there. These are the actually real components. Virtual components are not real. They are not available in the market. You cannot get them off the shelf in electronic store. So they are used to be able to simulate component values that you cannot predetermine, or that you just want to you know test first before you now do some analysis, so that you can now see which of the real components. Real components, they have um, they have their their footprint, they have the footprint, and they have the symbol. So the footprint is how the physical structure will be. Let me pick this. Let's say I pick this common diode. Now let me double click on it. Then I will go to uh, the pin information, and then I go to value. So when you see footprint, this you see DO5. That means it has a particular footprint that you can see. So you can click on the footprint. When you click on the footprint, you will see yes. Yes. Oh. Okay. I wanted to show us this component footprint. You will see some of the footprints that are going to. These are the footprints. The way they will be put physically. That is the footprint. But I'm going to cancel this because I just want to show you this. Now, I have gone through all this just to make sure that we understand different section of the master database. We have a transistor. You also have transistor virtual, as I said. If you don't have a real transistor value, you can use transistor virtual. So virtual components are very much available for you to use in your experiment, in your circuit. So you click on the group, you see analog. These are different analog circuits, components. We have operation amplifier, we have operation amplifier, we have comparators, we have all these things. So you as a student, you need to go through this and experiment with them one by one. These are different components. We have transistor logic. We have CMOS, complementary metallic oxide semiconductor. We have Masino digital. We have microprocessor, microcontroller you can use in your design. So being familiar with them is very important. You see mixed virtual, all these things. We're going to talk about RF timer. When you go to timer, you will see them. When we get there, you'll see what. Then you have indicators. These are our voltmeter, ammeter, probe, buzzer, a buzzer for like speaker. We have our lamp, virtual lamp, hexadecimal display. This is the bar graph. So in the bar graph, you can see decoded bar graph, level bar graph, and undecoded bar graph. So all these things are indicator. Probe, you want to put probe to check, to indicate something through the blinking. That's what we use. Ammeter is here, and we have the voltmeter. So because of our time, you just go through the other one. We have the RF, that's the radio frequency component. They are sensitive components that have been put here for us. Then we have electromechanical. These are mechanical, electromechanical components like sensing switches, momentary switches, all the switches that you can use in your electrical. We have single pole, single throw, double pole, double throw, all those things. You will get to know them as you proceed in your course. We have protection devices, and we have output devices that you can also try. So later, you will you'll need to do yourself a lot of good by going through them on your own. And also there's a quick link here. You can, this is a toolbar here. You can use to pick these components quickly. So quickly, before I round up this recording session, I will quickly look at building and testing a circuit on our figure 1. Building and testing. I don't want to do a long recording because of the time and because of other things. So I'm just going to look at the first laboratory assignment we did, building and testing a circuit. Now, I think I will need to do something. I want to introduce something very quickly because I discovered that many of you don't know how to put write-up on your work label. So you may need to know how to place text. Okay, so I want to place a text here. I want to place a text here. Just click on place. Click on text. Put here, then start typing. If it is capital, you see building and testing a circuit. Okay. Now, yes, so this is there for you to see. You want to make it bold, you can move it to the center and you can double click on it if you want to probably edit it. Okay, you can look at different things there. You can change the color you want, pen color. You can use another color and see. So these are, when you right click on it, you can get us. So quickly, let me just quickly do this. We have done it before, but because the video was not good, that's why I'm just doing it for the sake of emphasis. So I come back to sources and I reduce this so that I can continue. Power sources, what we start with, we pick our DC power. Then I put it here. This is for everybody. Then everybody to take note of. Then double click on it, change it to the voltage value you want. 10 volts is what is on our circuit diagram, the one we are following. Figure 1, labeled a resistive voltage divider. So you will have seen it in your manual. This is just a follow-up on the manual for you to have a better understanding. Then you also pick resistor. Resistor, we're looking for 500 ohms. Now, if you cannot get 500 ohms, don't forget ohms and kilo ohms are not the same, so always change. 500 ohms, here I'm seeing 510. So what I can do, if I cannot get the exact value, I can just use the basic virtual of the resistor. I can use, let me see what I can get. 500 ohms here. If I cannot get it, I will just use virtual. Okay, you can see I'm only getting 510, 499. So if you cannot get, just go to basic virtual and pick resistor virtual. And when you pick the virtual, you see the value will come up. You can double click and change it to the value you want. Can you see? That's the advantage of virtual. You can adjust the value to suit the one in the circuit diagram you are capturing the schematic. So this is what we call schematic capture. Don't forget, the first stage is to capture the schematic before you simulate. Capture schematic before you simulate. So Then here, I need to flip it 100%. Then I copy again, this same, I copy again. I try to copy and I paste. I copy again, I paste. I copy again, I paste here. I quickly, I can arrange to move it to where I can easily do the wiring. Okay, I can do the wiring now. So as you just move your mouse, the wire will come out, then you move it, and then you join it, okay? Just move your mouse to any of the ends of the component. The wire will come out, and then you can easily complete the circuit. Okay, so this is ready now, but I should not forget to put the ground. I need to put my ground. Okay, the ground is the reference point to the circuit, reference point. So I can now put the instrument or the indicator. I've done the arranging the circuit element. So follow the manual, you see the first step, place the component on the circuit window. The second step is arranging the circuit element, then wire, step number 3, wire the component together. Then step number 4, set values for the component, which I've already done, I've combined together. Then save your circuit, very, very important. Always try to save your circuit for the sake of continuity. If NEPA takes life or something happens to your system, you can easily continue from where you stop. So I'll save it as figure 1 on our manual. Okay. So the next thing is to attach the voltmeter. Step number 6. Attach the voltmeter. So where do you get the voltmeter from? From our indicator. Click on place indicator, voltmeter, click on voltmeter. There you will see there are different voltmeters. You see voltmeter horizontal, that is dash H. I mean voltmeter underscore H, then voltmeter underscore HR, then voltmeter underscore V, then voltmeter underscore VR. So what do this mean? It means the first one is horizontal connection. Second one is HR, horizontal reverse. So the polarity will be reversed. Then the next one is vertical as it is, vertical. The first one is horizontal, H. Then the next one is horizontal reverse. Then the third one is voltmeter vertical. So when you click on them, you will see how they look like. You see this is vertical. So your terminal connection will be vertical. And then you have vertical reverse. The polarity will be reversed. So here you can see we need vertical because from the circuit you see that we need to put it in the vertical position. So, and we want our positive. You can try vertical, positive up, negative down. When you put that and then you discover any problem, you can reverse it anytime. You can easily replace it. So quickly, I want to add this because of my time. My time is running. So this is our first lab now. This video replaces the first video I should have uploaded so that you can have a better understanding of this. And also you can put another one. From the place indicator, you can put another one. I will be running up very soon, so just so let me quickly add another one here. so that I don't have to come back again. Okay, so now the next thing I need to do is to do what we call, from my tools, I will do electrical rule check. This is I'll just click on report also unconnected pin. I will remove this so that do not, now you see completed, 0 error, 0 1. That means all my circuits are connected properly. And so with this, I can go ahead and simulate. I can simulate with this run stop simulation, or I go to simulate, I click run. So you can see the circuit will start running. Can you see? So you see, when it starts running, the simulation, you see the voltages on the voltmeter reading 5 volts each. And this is where you can now stop the simulation, and you can now adjust. You can adjust the value of the component. Okay. See if you can change it to 1 kilo and see how it behaves. Okay, this is 1 kilo ohm. This one is 500 ohms, and then I simulate again. See the difference in the voltage across the resistor. So this is actually a voltage divider. It drops equivalent voltage that correspond to the current passing through it. So later you can also look at, you can put a voltmeter there. Ammeter to test the current flowing. So this we can do in the next broadcast. Thank you very much. If you have any question, you can leave your comments, and also you can contact me on the number. So we'll meet in the class for more lectures and lab tutorials. So bye for now.